Yo, what up homies? My name is Zara and today I'm going to teach you about something that I think is pretty insane. So in 2016, NVIDIA drove around for thousands and thousands of kilometers, and then they fed this information into an artificial intelligence model that basically looked at the images, looked at the steering angles, and just figured out what the correlation between the two was. So then when you put this system into a self-driving car, it just knows how to drive. It just figured it out. And that's really insane. I'm about to explain to you exactly how that technology works. So they use something called end-to-end learning, which is a totally new step in the machine learning field. So let's take a step back and learn about what regular machine learning looks like. So a model takes the inputs, X, and converts it into an output Y. But there's several things that happen in between. Information and numbers in the form of calculations are passed from node to node throughout layers of the neural network. Say I wanted to make an artificial intelligence model that could differentiate between an alligator and a crocodile just based on image input and some labels. In traditional machine learning, the criteria is usually human picked. Going back to the alligators and crocodiles examples, I might decide that I want my neural network to look for the snout shape. Alligators have really round snouts, whereas crocodiles have really sharp and pointy snouts. Another difference between the two is that crocodiles have teeth that stick out of their mouth, whereas alligators have most of their teeth hidden inside their jaws. So my regular machine learning model is going to look for these features in specific, snout shape and where it lives. But what if I made a mistake? Which is very likely because of the amount of mistakes humans make. Just a side note, 95% of car accidents are caused by human error. So as you can see, humans do make a lot of mistakes. So then NVIDIA got an idea. This is my broken light bulb. I broke it as I was trying to set up my lighting for this video. So as you can see, humans make a lot of mistakes. Okay, so back to NVIDIA's idea. Here's what they did. They decided, what if we had our input X and then our output Y, but then nothing in between? What? How would that even work? Well, let me tell you. It did. The hypothesis regarding end-to-end learning was that end-to-end learning would allow for better performance and smaller systems. Let's talk about better performance for a moment. So remember how a lot of the criteria of regular machine learning is usually picked by humans, and humans might not be right? So the reason end-to-end learning would have better performance is because the machine can learn on its own what criteria is actually the most crucial in the correlation between the X and Y variables. A human might think that a very crucial part of driving was lane detection and then tell the AI system to look out for this in particular, but they might be wrong. It's actually not. NVIDIA proved this wrong. So if we didn't tell the car to look for lane detection in particular, it would probably just figure out the best criteria to look for when determining the steering angle. The system would also be smaller. Because we go straight from X straight to Y, everything that happens in between is left up to the computer to self-optimize. So the humans don't get to pick what tasks they think are necessary. Instead, the computer figures out what steps in the process are completely 100% the most crucial steps in the process, and it can get rid of everything else. Here's what the car did after all of their work without all the intermediate steps. Here's what happened. NVIDIA hired drivers to drive their cars around and recorded training data. The training data came in the form of a visual, so it was a video of what the car sees on the road. The steering angle was also recorded through the CAN, or Controller Area Network. NVIDIA used the CNN, or Convolutional Neural Network, to look through all of the visual data that the cars picked up. This is because CNNs completely revolutionized the world of image recognition for its automatic feature learning, 2D nature, and the kernel controllability, so that you can keep the parameters of the whole system pretty low to keep the system as small as possible. In a nutshell, the way a CNN works is it has a kernel that depicts a certain feature of an image. For example, one feature we could potentially be looking for is perhaps a diagonal line. Where else might you see a diagonal line? Probably on the roads in the lane lines. So So this kernel depicts that feature and it convolves through the image. That just means it goes through the image and checks how closely different parts of the image match the feature depicted in the kernel. Then this information would be packed into a feature map, so instead of storing the whole image, the computer just has a really good understanding of what kind of features and patterns are actually in the image. And it's stored in a way that's easy for computers to understand in numerical data. Then what the model does once it has a pretty good understanding of an image is it takes a look at the steering angles. So the steering angles are recorded through the CAN, or controller area network. It's recorded like this: I over R, where R equals the turning radius in meters. Now there's a specific reason why they did this, and it's that the angle of driving straight is actually equal to infinity. And you can't have an infinity steering angle. That would most likely just confuse the network. If the steering angle I over R comes out to be a negative number, then that is a left turn. And if you have the steering angle come out to be a positive number, then that is a right turn. When it's time for the cars to actually drive on their own, based on the steering angle prediction of the model, the controls are outputted to the drive-by-wire interface, which is a system that augments or completely replaces the mechanical controls of the car. So for example, the steering or the pedals. So then the convolutional neural network takes a look at the image and then compares it with the steering angle. Now the network just has to figure out, through tons and tons of data, what is the correlation between the two. Here is the network architecture. We can see that we have a ton of convolutional layers in the beginning and then a couple of fully connected layers towards the end to actually get the information through to each other so that we can take a look at what the outputted steering angle prediction should be. And then the model makes a prediction as to what it thinks the steering angle should be based on what it sees in the image. Then it compares the model's predicted steering angle with the actual inputted steering angle provided by the human during the training. Then based on these two numbers, the error and accuracy is calculated. Then the model slightly readjusts itself to decrease the error and increase the accuracy. If you like this video, I highly recommend you leave a comment, a like, share it with your friends, connect with me on LinkedIn or send me an email. I will leave my contact information in the description down below. Feel free to check out any of my other videos and subscribe to my channel for more really cool stuff like this. Until next time, my name is Zara. I hope to see you guys again soon.